Hello everyone, welcome to the next session of ANSYS Workbench tutorials. In this session, we are going to discuss about the procedure for solving for a plate with a circular hole in it. We will see the procedure for finding out the total displacement and the equivalent stress which is generated on the material due to a particular load on it, and we will discuss about the failure of that plate. So we will start with static structural by double clicking on it. I'll first go to geometry, right click, new design modeler geometry. I'll go to units, millimeter, XY plane is what I'm going to choose, look at. Next I'll go to sketching, rectangle. I'll draw a rectangle and I'll give it dimensions. Say H1 is 100 and H2 is 50. Now I'll extrude this plate. Say the depth is 20 mm. Generate. Now on this plate I'll draw a circular hole. So I'll first choose face. I'll select a face, new plane, generate. I'll click on look at. Then I'll go to sketching and I'll choose circle. I'll draw a circle. I'll give it dimensions. Say the radius is 10. Also I'll give one more dimension, that is its position from this end. I want to place it at the center. So I will give this dimension as 50. And I also want to give its dimension from this end. Again at the center. So this will be 25. Next I'll go for extrude. The circle has been selected. Apply. Operation will be cut material so that a hole is generated. The depth is 20 mm. Generate. So you can see here I have made a hole in this plate. This is my simple geometry. Next I'll go to model and double click on it. Now I'll go to mesh, sizing. I'll change the relevant center to fine. I want to see the statistics of the mesh. You can see here the number of nodes are 93431 and elements are 21,008. So this is for the fine mesh that I have taken. Now when you have a hole in a plate, this hole is the area where your maximum stress can be generated. It can lead to notch sensitivity, that is, over here if suppose a small crack is generated, it will propagate very fast because of this hole. So we need to have more refinement of mesh in that area. So I will go to mesh, right click, insert, refinement. Now it is asking for a geometry, so I'll select this small hole area, apply, and I'll go to update. Now you can click on the mesh again and see the nodes and the element number. They have increased than the previous case. So here you can see the amount of meshing in this zone has increased so that we are able to get better results and we are able to get the values which will indicate the stress at these points very accurately. Now I'll go to analysis settings. I want to apply boundary conditions. So I will select this face, right click, insert, fix support, and say I am doing an analysis where I apply a tensile load at this end. So I'm going to insert force. You can see the direction is X. I'll change vector to component. Along the X axis, say I apply a load of 10,000 Newton. So I've applied. Now we will also discuss about the geometry and the material that we have associated to it. You can see the default material is structural steel. So we will discuss a bit about it. We will go to engineering data and double click. Now you can see here we are at structural steel, which is the default material. We will discuss about this point number 12, which is in the property outline. You can see here. So when you go to this alternating stress, mean stress, you can see here these are some values. We will change this interpolation to semi-log form and we will see the results for it. We can see here this graph and also the stress in this material. Now let me talk about this value in megapascal. You can see here for a particular number of cycles, that is the amount of loading which you can apply and remove. Cycle means you apply the load, you remove it, again you apply the load and you remove it. There are various types of applying load. For example, you can start from 0 and you can go to say some value of 50 kilonewton and you can say the load is applied, so you want to see the stress. This is one type of loading. Another type is you go from 0 to 50. From 50 you go down to 0 to minus 50, again to 0 to 50, then 0 minus 50. This is called as an alternating way of applying load. So you go from 0 to positive value and from positive to 0 to negative value and back to 0 and positive again, and the cycle continues. So there are various ways of applying load from 0 to maximum. That is called as a step input, or you can have alternating cycles like your sinusoidal wave. So you can have different way of loading. Now for that, whatever pattern you choose to apply the load as, for this material, structural steel, you can see here the alternating stress or the maximum stress that the material can endure is 86.2 megapascal. If suppose you apply a load such that your stress generated in the material is more than this 86.2 megapascal, it will mean that your body is going to fail after performing for some time. So you need to be careful with the load that you apply. So that is nothing but your factor of safety. When you talk about the life of the body, or you say that amount of load that is applied and the yield stress, endurance limit, these are the certain terms associated, and this ultimately takes us to the calculation of the life of the body. So we will use this material, structural steel, and with the amount of load that we have applied, we will try to figure out if my body is going to sustain that amount of load that we have given. So now we'll go to solution, right click, insert, deformation total, and I also want to see the stress equivalent, that is von Mises stress on the body. I'll go to solution, solve. We'll first see the total deformation on the body. So you can see here you have applied fixed over here and a load in this end. So this is how your total body is going to deform. You can see an animated view of it. And you can see here the maximum deformation will be in the red color on this body. So we can click on max min and we can see where the maximum deformation will occur. Obviously it will occur at the end where you are applying the load, and the minimum deformation will be at the end, which is fixed. So that's what is shown here. Next we will go to equivalent stress, and you can see here the stress which is generated is 37.17 megapascal, which means that my body is safe because the maximum stress it can endure is 86 megapascal. The amount of stress generated because of the load of 10 kilonewton that we have given is leading it to a stress of 37.17 megapascal, which means the body is safe. Now suppose if I change this value of loading, you can see this is 10 kilonewton. Let me change this to 100 kilonewton. and let's check. Suppose if the stress generated is less than the maximum stress it can endure, it means my body is going to be safe with the number of cycles that is predicted, that you saw here. So these are the number of cycles that the body can work for, or these many number of times you can keep on applying the load and removing the load, and the body will sustain with that load, 10 kilonewton. Now suppose if we talk about 100 kilonewton, you can see here there is a difference of total deformation over the body. Let's talk about the equivalent stress. You can see here it is 371.7 megapascal, which is much more than your endurance limit or the maximum value of the body. So that is why for this load of 100 kilonewton, your body will definitely fail, not immediately, maybe after performing certain number of cycles. This is how you analyze a plate which has hole. You can see here at this whole area there is maximum and minimum amount of stress that is generated, and here you are going to have the initiation of a crack. So the crack propagation starts from this zone where you have more amount of stress acting, and then it will spread over the entire body. So with this I end the session. I hope you have understood how a plate is to be analyzed with a hole in it. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to my channel. Hit the bell icon for latest updates of my videos. See you in the next session. Thank you.